Welcome to the data structures class. So today's topic is dictionaries representation. So in the last class we have discussed the dictionaries. So what is dictionary, how we can represent the dictionaries and the examples of dictionaries. Okay. Now let's discuss how we are practically implementing these dictionaries in the program. Now let's review once again what is dictionary. The dictionary is a group of values or objects. These can be stored with the help of key. So if I want to access a data, I need to access through a key. Am I right? I need to access through a key. So these dictionaries can be a ordered or unordered dictionaries. So this can be in an ordered manner. So like 1, 2, 3, 4, 5, 6, like this we can store the values in a dictionary. Otherwise you can store the values randomly. So 1 after 10, 10 after 20, 20 after 2, like that you can arrange the values in a dictionary. So it is ordered or unordered. But for real-time applications, it's best to use a dictionaries in a ordered manner. So I'm going to explain the process for a ordered dictionaries. Okay. Now, so the basic applications of a dictionary are symbol tables. As we previously seen, the main applications are like a bank table, bank account details, or if I want to access a student data, those also can be treated as a dictionaries. And other than those, the symbol table for compilers and the routing tables for communication. So for communications, we see I'm giving lecturing through a video lecture here. I'm uploading the data from one location. It is uploaded in another place, and it will be distributed to your respective devices. So these will be distributed through some hubs. So how can this video or this resource reaching you? It can be routed. Those routing will be based on the also dictionaries like the dictionaries also. So these routings also can use as dictionaries. So page tables. So in the operating system, if any process wants a resource from the main disk, so it needs to be accessed through a page tables. And spell checkers, as you seen in the previous one, while we are using tries, if I want to access a 10, it should be flow from T to E and N. So it is also based on the dictionaries only. So these are some of the applications dictionaries where we are using in the real world. Now the implementation, that means you can represent the dictionaries in a programming. I'm especially talking about a C language. So in this we can represent by using a linear list or skip list. So you know the operations. So every data structures contain the common operations. Those are insertion, deletions, and display. So modification is also comes under one of the operations, but the main operations we will treat it as a insertion, deletion, and display. So insertion of a value is nothing but so if I want to insert a values, first I need to know the structure. Am I right? So now I am explaining the structure based on the linear list. Linear linked list. So linear list, mostly we are using a linked list. As you know, a linked list contains this data type. How we are going to store the values in a dictionary? The data and the next address field. The next element address. So like this, we will store the data in a linked list. If it wants to apply for the dictionaries, see dictionaries stores the data as well as the keys. So for that, for linked list, it has an extra field that is a key. So if I want to implement this linked list properties to my dictionaries, then I have to use the structure like this: the key, data, and address. So linked list I need to create with 3 fields. As you know the structures for linked list, we are using the structures. Am I right? So the structure of a linked list for dictionaries is like this. So now here is dictionaries I have created or I declared. Now the data type and key and data type value and the structure, the next address field. So these three will be stored for each and every node in a dictionary. So data type is based upon your data. So mostly we are using the integer data. So here int key, int value, and struct dictionary next address field. It is a pointer to store the next address field. Am I right? So it is the structure for creating a dictionary through linear linked list. So obviously, while you are creating at the starting, the head will become as a null. So without any elements, we will create a dictionary. Okay. Now, see, if a dictionary wants to insert a values 90, 86, 76, if it is a linked list, then I will directly store the 90 or 86 or 76. But if it is a dictionary, so dictionary need a key. So here the values, I can say values than a key pair. I can say a key pair. What is key pair means? Key and value. So in dictionaries, the values are termed as a key pairs. So here the key pairs are 290, 586, 2076. If the values are like this, the dictionary of a linear linked list will be like this. So the head, the first position, it is representing the 2000. So 2000, at the 2000 position 90, and the key is 2. Am I right? The first value is 2 and 90. Now the key is 2. At the key 2, I have a value 90. Okay. Now it is representing to the next element 3000. At the 3000, I have a value 586, 4000. So at the 4000, the next element is 76. 76 with the key 20. And the next element is null. That means it is the end of the linked list. So it is the dictionary linear linked list representation if I have a key pair of 290, 586 and 2076. Okay. Let's insert a value one by one with this process. Insertion. The insertion is nothing but if whatever the key value I am inserting, if it is a new one, then I will insert the value according to my position. Why? Because I am using a process of ordered list. Ordered means I have to search the respective place. All right, I have to insert according to the order. Okay, for first I have to check for the order and place, then I will insert it. First, suppose if I have a data already existed at that key, if I have a data already with that key, then I will modify the data. So insertion is nothing but either inserting a new value or new key pair. If the key pair is already existed, then I will update that key pair. That is the insertion process. Okay. Now, so the process, see here linked list, if you see in the first unit, the linked list insertion operations are 3. The first one is I can insert a value at the starting, or I can insert a value at the end, or I can insert a value at the desired position. So in this process, in this dictionary, so I am inserting the values according to my order. So there is no specific thing to fix. So can I insert at starting, can I insert at the end, or can I insert at the middle? I don't know. Why? Because it is depending upon the order. I can insert at the starting, or I can insert at the ending, or I can insert at the middle. This depending upon the key. Now I want to insert a values. So in this example, I will insert 4 values, that is 290. The key value pairs are 290, 1186, 465, 500. If I want to insert, so first the process is as you know, in the linked list also, if I want to insert a value, first I will create a data, or will create a node with the given value. So I am creating a value node with the given value. Now the node is created. So 290, and the automatically next address field is null. So initially I will treat it like this. So it is created at the 2000 position. Now where I have to insert? First I have to create a node, then I will insert the value. The same in the linked list also. Whether I am inserting at the start or end or at middle, let's see the process. Okay. Now if I want to insert, first I will create a node. Then after creating a node, I am checking whether it is empty or not. How to check? Check here. Here, if the head is null, then automatically it is empty. If it is empty, the new node will become as a head. It is the same in the linked list also. Am I right? So I can say it is a insertion at the start. So now my head element is 2000. Now my head element is 2000, the only element available is this. Now I want to insert another one, that is 1186. I want to insert a value 1186. Okay. Now 1186 is inserting. Now what I have to do? First I will create a node with the given value. Now I created a node. Now at the 3000 position the new node is created. Now where I have to insert? So first I am checking whether it is empty or not. It is not empty. If it is empty, then automatically new node will become as a head and then the process is closed. It is not empty, then what I have to do? I have to search for the appropriate position. I have to search for the appropriate position. Now how to check? The same thing. First I will read the head value into a temporary variable. Now what is head value? Head value is 2000. So temporary contains the address of 2000. That means node 30. That means node 90. Sorry, node 90. Now next I will check whether this key value is less than the inserted one or not. See, if it is less than, then I will move to the next one. If it is greater than, then I have to insert before that key. For suppose if the key is 1, whatever the value I want to insert the key 1, then I have to insert before 2. Alright. So now I am checking where I have to insert value. For that, now it is depending upon the keys. So temporary key is less than the new node key or not. So what is temporary key? So temporary variable is 2000, 2000 key is 2. Is 2 less than 11? Yes. Then I have to move to the next node. Okay. Like this I have to move to the next node until I find the final one, until I find the appropriate position. See, how much time I need to check for the next node? Until I face the empty one, until I face the last node. See, if you see this process here, the 290 next element is null. That means it is the last element in this dictionary. So after finding the last element also, if I didn't paste any suitable position in the middle or starting, then automatically I will insert the value at the last. See, once again, I am temp equals to head. First I will read the head value into a temporary. I am checking whether the temporary key is less than a new node key or not. If it is not, if it is less than, then I will move to the next one. How much times I need to move to the next one? Until I will find the last node. If I move to the next one, then again I will check for the temp key equals to not equals to or not, less than or not. If it is again less than, then I will go to the next one. So this complete process will work until I find the last node. See, if I find the last node, then also I didn't find a greater value of the key, then automatically that new node I will insert at the last. If I find the greater part of the key than the insertion key, then I will insert before. So like I said, if I want to insert 1, I will insert before 2. Okay. So once again, if I want to insert a value, I need to represent with the key. If the key is a less than, already have the key, then I have to insert before. If it is a greater than value, then I will move to the next one and I will check for the until I find the greater value. If I didn't find the greater value after reaching the last element also, then I will automatically insert the new value at the last of the linked list. So I find the last element and I didn't find the greater value of the than the desired key. Okay, then I automatically insert the value after a last node. Okay, now the 3000, now this 90 is representing to the 3000 is the new key 1186. Like this I will insert the values in a dictionary through linked list. So in this last example, first element is inserted based upon the inserting at the beginning. The last one I inserted 86, that is inserted is based on the insertion at the end. So first the process, I will create a node with the given value and checking whether the value is whether dictionary is empty or not. If it is empty, then automatically it is treated as a head, and that's the only element available in the dictionary. If it is not empty, then I will check for the keys. I will check for the appropriate place. So how to check? First I will read the temporary variable head value into a temporary variable and checking whether that starting element key is less than the new node or not. If it is less than, then I will move to the next step, and again I will go to the step 4. Again here I am checking that next node key is less than the targeted key or not. I will go like this until I find the last node. If I didn't find the value, I will go until the last node. If after last node also, if I didn't find the appropriate position, then I will insert at the end. If I find, that means if I find the greater value here, then it will goes to the step 9. That means I will insert the value before temporary value. This is the process. Okay, let's insert once again. So I need to insert the 2 more values, that is 465, 500. Now I am inserting 465. So first, what is the first process? I have to create a node with the given value. I created one. I am now checking whether the list is empty or not. It is not empty. Then I have to find the appropriate position. The first one, the temporary value, head equals to temporary. So head value is 2000. So now 2000, temporary value is 2000, and checking whether this 2000 key is less than this one or not. So it is 2 less than 4. So what is next? I need to move to the next one. So next one means 3000. So now temporary value is 3000. Now again I am checking whether this 3000th position key is less than or not. Not a less than. It is a greater than value. So that means I need to insert this 4 before 11. I need to insert 4 before 11. Okay. Now the process will be like this. So here the process is a linked list insertion between elements, or insertion at the desired position. Alright, that process will comes here. Now see here, previously it is representing to this one, it is representing to 11. Alright, previously it is representing to the 11th key. Now it must represent to the 65, and 65 represent to the 3000. Now the complete process, the 290, it is referring to the 465, 465 is referring to the 1186. Like this I will insert the value. So for suppose if I want to insert 500, the 500 should be, see, 2, then 4 and 11. So it should be insert between 4 and 11 and 4 and 11. So the new value will be inserted like this. So these are the operations of a insertion in a dictionary. So dictionary representation, how we are representing the data in a programming manner, how we are representing by using a linked list or a skip list. So we have discussed in this class how we are representing the data in a linked list. In the next class we will represent how we are representing it by using a skip list. Thank you.